You are watching Picard Jr.'s channel.
About 190 light-years from Earth, in the depths of the constellation Libra, lies a true enigma of the cosmos. The star HD 140283, better known as the Methuselah star. At first glance, it appears to be a common star, nothing special. However, it holds a secret that has intrigued astronomers for decades. Despite not being extraordinarily large or bright, something in its composition challenged the foundations of science. At one moment, it seemed like just another star to be studied. The next, it sparked a debate that would shake the certainties about the age of the universe.
Now let's stop and subscribe and like the channel. Our channel knows about all the things that happen.
In the 2000s, a precise calculation of its age revealed something astonishing. Scientists discovered that this star was not only ancient. It appeared to be 16 billion years old, 2 billion years older than the universe itself. An estimate that, if true, threatened the scientific understanding of the origin of the cosmos. From that moment on, the Methuselah star became a symbol of mystery, like a relic of the universe that shouldn't exist. It placed the scientific community in front of a fascinating dilemma. Either the universe was older than we thought, or stellar models needed to be drastically revised. The universe, after the Big Bang, was a boiling soup of subatomic particles, protons, neutrons, and electrons, that, over time, began to cool and combine into simple atoms, mainly hydrogen and helium. These first elements formed gigantic stars, known as Population 3, which have never been directly observed, but are believed to have masses up to 300 times greater than our Sun. These stars lived quickly and ended their lives in colossal explosions, called supernovae, which spread heavy elements across the cosmos and gave rise to new generations of stars. HD 140283, in turn, belongs to a class called Population 2, stars formed from the remnants of these first supernovae. They contain some heavy elements, but in minute proportions, revealing their great age. In the 1950s, spectroscopic analyses detected that the star had only 0.4% of the iron found in the Sun, suggesting that it formed before these elements became common. Still, the 16 billion year estimate for its age caused a shock in the scientific community. How could a star be older than the universe itself? The age of the universe is estimated to be about 13.8 billion years, based on cosmic background radiation and the observed expansion of space. However, this dating is not immune to revisions. In 2023, a study suggested that the universe could be up to 26.7 billion years old, but this remains controversial. Even so, the Methuselah star challenged these assumptions and raised questions about the accuracy of the calculations. The most intriguing thing was that every attempt to estimate its age resulted in values close to or exceeding the accepted age of the universe. To solve this mystery, a team of astronomers from Pennsylvania State University carefully reviewed the data collected by the Hubble telescope between 2003 and 2011. With more precise measurements and adjustments to stellar evolution models, they managed to recalculate the star's age. Although the new estimate suggested the star was 14.46 billion years old, still above the official age of the universe, there was a margin of error of 0.8 billion years, which could place its true age within known cosmological limits. The search for answers didn't stop there. In 2014, new studies reduced the estimated age to 14.27 billion years, and in 2021, to 12 billion years, finally, a comfortable dating compatible with the universe. Although it might seem anticlimactic, this scientific journey demonstrated how each discovery leads us to revisit and refine our understanding of the cosmos. The Methuselah star did not overthrow the Big Bang theory, but it played an important role in challenging the limits of our certainties. More than a resolved enigma, the story of this star reminds us that science is a continuous process of refinement and learning. Even with all the advanced technologies, the assumptions that underpin scientific knowledge need to be constantly questioned. The story of the Methuselah star is an example of how scientists revise their models and adjust their conclusions as new data emerges. And it is precisely this humility and openness to the unknown that allows science to advance. Although we now know that the star is not old enough to break cosmological paradigms, its discovery and study are still impressive. First detected in 1951 as one of the earliest stars to show low levels of heavy elements, it was essential for astronomers to understand the origin of elements within stars. Research on this star has influenced generations of scientists and will continue to inspire future investigations into the formation and evolution of the universe. Currently, the Methuselah star is in the subgiant phase, the stage our Sun will reach in about 5 billion years. Eventually, it will exhaust its fuel and transform into a white dwarf, glowing faintly for trillions of years until it completely fades away. To us, human beings, it seems incredibly old, but in cosmic terms, it's just a youngster. Even with its apparent ages and margins of error, the fact is that the Methuselah star will continue to shine for a long time, serving as a reminder that the universe is vast and enigmatic. What's most fascinating is that, despite its age and distance, this star is not entirely out of reach of our curiosity. With a pair of binoculars and a bit of patience, it's possible to spot it in the night sky. Gazing at the Methuselah star is to contemplate one of the oldest objects ever observed by human eyes, a link between the universe's distant past and the present. And so, even if it didn't break the universe as we expected, it gave us the chance to reflect on our place in the cosmos and the many questions that still need to be answered.
That's it, guys. Don't forget to like and subscribe to the channel. Live long and prosper.